Think Maths. So in this session, we are going to discuss about exercise 1.4, question number 2 and 3. So in the last video, we solved the question 1. So which is nothing but they will give you a rational number. We have to check whether the decimal expansion of this rational number is terminating or non-terminating. Okay. So here, question number 2 says that write down the decimal expansion of those rational numbers in question 1 which have terminating decimal expansion. Here the questions that have terminating decimal expansion are 1, 2, 4, 6, 8 and 9. So all the questions have been solved in previous video. So if you want, you can refer the video. Now let us go into this problem. This is question number 2. The first question is 13 divided by 3125. Okay. So first let us check the denominator. So the denominator should be of the form 2 power n into 5 power m. So if it is of the form 2 power n into 5 power m, then we can say that the decimal expansion is terminating decimal expansion. So first let us check that. So the numerator cannot be factorized because 13 is a prime number. So first let us factorize 3125. Okay. So 3125. So as it ends with 5, I take the prime number 5. So 6 5s are 30, balance 1, 2 5s are 10, balance 2, 5. So 625, again I take 5, 1 5s are 5, 2 5s are 10, balance 2, 5 5s are 25. Again 5 is taken, 2 5s are 10, balance 2, 5 5s are 25. So 5 5s are 25. So I take 5 1 times. So 5 is repeated 5 times. So I can write as 5 to the power 5. So it should be of the form 2 power n into 5 power n. So to bring to this form, I divide both numerator and denominator by 2 power 5. So 13 into 2 power 5 divided by 2 power 5 into 5 power 5. So what is 2 power 5? That is 2 multiplied by 2 multiplied by 2 multiplied by 2. So it is 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So 13 into 32 divided by, so I am going to write this as 2 into 5 to the power 5. Okay. So first let us find the value of 13 into 32. So you can just multiply regularly to find the value of 13 into 32. So otherwise I will tell another method, that is 13 into 32 can be multiplied in two ways. Suppose the answer is x, y, z. So usually in mathematics we will fill up the answers from units place, that is ones place. So let me calculate the ones place z. So for z, you have to multiply the ones place. So that is 3 and 2. So 3 2s are 6. Next for y place, you have to find the product of the inner values. So inner values are 3 into 3. Okay. So 3 into 3 plus product of the outer values. Outer values are 1 and 2. So 1 into 2. So 3 into 3, 9. 9 plus 2, 11. So y value is 11. So z, you have to find the product of the tens place. Tens place are here 1 and 3. So 1 into 3, 3. So the answer will be 6. Y value is 11. So I write 1. Balance will be 1. So z value is 3. 3 plus 1, 4. Okay. So the value is 416. So the answer is 416 divided by 2 into 5, 10. So 10 to the power 5. So we have to keep 5 decimal points before this. So already there are 3 places, 1, 2, 3. So adding 2 zeros, there will be 5 places for the decimal. So 0.00416, because in the denominator there will be 5 zeros. So before 5 places, you have to keep the decimal points. So 1, 2, 3. So there are 3 values. So adding 2 zeros, we can find the decimal places here. So answer is 0.00416. So then let us go to next problem. So next problem is 17 divided by 8. So 17 divided by 8. So 8 can be easily written as 2 to the power 3. So 2 2s are 4, 4 2s are 8. So to make the denominator as 2 power n into 5 power m, so I multiply denominator and numerator by 5 power 3. So what is 5 power 3? 5 power 3 is 5 5s are 25. 25 into 5 is 125. So 17 into 125 divided by, this can be written as 2 into 5 to the power 3. That is 10 power 3. So we have to find the value of 17 multiplied by 125. You can just regularly multiply, or you can use a Japanese trick which I will show here. That is, for the first number 17, you have to draw lines. So for this 1, I am going to draw a line, one line. So leaving a gap. Next number is 7, you have to draw 7 lines. 1, 2, 3, 4, 5, 6, 7. So for the next number 125, you have to draw lines in this direction. Okay. 1. For the number 2, 2 lines. 1, 2. For the number 5, 3 lines. 1, 2, 3, 4, 5. So next you have to find the answer using intersection points. So this is zone 1 and this is zone 2. This is zone 3 and this value is zone 4. Okay. So in the zone 1, so how many intersection points? The point where 2 lines meet is the intersection point. So you can count one by one, or just you can multiply the lines. That is, here there are 5 lines and here there are 7 lines. Okay, so 7 5s are 35. So this value is 35. Next is zone 2. Here how many lines? 1, 2, 3, 4, 5. So there are 5 intersection points. 5 plus here 1, 2. It is 2 into, how many lines are there? 7 lines. So 2 into 7, 14. Okay. So 2 7s are 14. 14 plus here 5 points are there. So 14 plus 5 is 19. Okay. So next one. 1, 2, 2 points are here. Here 7 points are here. 7 plus 2, 9. Here 1. So now we have to write the answer. That is, starting from the ones place. 35. So you can write 5 here. Balance will be 3. So next it is 19. So 19 plus 3, 22. Balance will be 2. Here it is 9. 9 plus 2, 11. So balance is 1. 1 plus 1, 2. So the answer for 17 into 125 is 2125. Okay. So I will erase this balance. Divided by 2 into 5 is 10. So 10 to the power 3. So there are 3 zeros here. So you have to keep the decimal point before 3 places. 1, 2, 3. So here comes the decimal point. So 2.125 is the decimal expansion of 17 by 8. So this trick is called the Japanese trick. So you can practice and you will get the multiplication easier. Okay. So let me go to the next problem. So next problem is 15 by 1600. So we have to partition, that is factorize 1600. Okay. So let me factorize 1600. So I am taking 2. 2 8s are 16. Zeros will come here. Again 2 4s are 8. Zeros. 2 2s are 4. Next I am taking again 2. 1 2s are 2 and zeros here. Next 2. 5 2s are 10. 0. Again 2. 2 2s are 4. Balance 1. So 5 2s are 10. Next I will take 5. 5 5s are 25. So I can stop here. So there are how many 2s here? 1 2 3 4 5 6. So 2 power 6 into 5 power 2. So in order to balance both this, so I add again, that is I multiply again 5 power 4 because we can get the powers will be same. So we can write as 15 divided by 2 power 6 into 5 power 2. So these two values cannot be multiplied and we can write as 2 into 5 to the power because their powers are not same. So to bring the powers to same, I multiplied by 5 power 4 on numerator and denominator. Okay. So 15 divided by, before that we can cancel some values, right? Okay, just a minute. So here 15 can be written as, just a minute, before that 15 can be written as 3 into 5, right? Divided by 2 power 6 into 5 power 2. So 1 5 will be cancelled here. So 3 divided by 2 power 6 into 5. So how many times you have to multiply? You have to multiply by whatever it is. Anyway, you have to multiply by. So either you can follow this or you can just multiply by 5 power 4. So again I need to multiply by 5 power 5. So in both the cases the value will be same. So you can just follow any one thing. Okay. So here I will follow the first method, that is instead of cancelling and again multiplying. So I am going to follow the first method, that is 15 into, so I am going to multiply by 5 power 4 divided by 2 power 6 into 5 square into 5 power 4. Okay. So 15 into 5 power 4 will be, that is 5 5s are 25. Again there will be 2 5s. So 25 into 25 is 625 divided by, so there are, the powers are same for 2 and 5. So I can write as 2 into 5 to the power 6. Okay. So here also you can follow the Japanese trick to multiply 15 into 625. I will show you that. Before that I will erase some values. Okay. So I write this here. 15 into 625 divided by 2 into 5 to the power 6. So for following Japanese trick, you have to draw lines, right? So I erase some values to get space. So for 15, you have to draw one line. For 5, 1, 2, 3, 4, 5. Next, for next value 625, you have to draw lines in this direction. So 1, 2, 3, 4, 5, 6. Next value is 2. So you have to draw 2 lines. 1, 2. Next 5, 5 lines. 1, 2, 3, 4, 5. So you have to partition into zones. So this is the first zone and this is second zone and this is third zone, and this is the last zone. Okay. So what is the value here? Here there are 5 lines and here also 5 lines. So 5 5s are 25. Next here 5 plus here 2 into 5. So 10 plus 5 is 15. Here 2 points are the intersecting points. Okay, so we are calculating the intersecting points, right? So you can just calculate one by one or you can use some multiplication tricks. Okay, so here 1, 2. So I am counting the intersecting points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay. So you can count one by one or use just here there are 5 lines and here there are 6 lines. So 6 5s are 30. 30 plus 2 is 32. Here there are 6 intersecting points. 1, 2, 3, 4, 5, 6. Okay, 6 intersecting points. So the answer is, so starting from the ones place, for 25 I write here 5, balance will be 2, so 15, so 15 plus 2 is 17, balance is 1, 32, 32 plus 1 is 33, so balance is 3, next is 6, so 6 plus 3 is 9. So the answer is 9375 divided by 10 to the power 6. Okay, so you have to place the decimal point before 10 values. So 1, 2, 3, 4. So we have to add 2 zeros. So 0.009375 is the decimal expansion of 15 by 600. Okay, so next problem. 23 divided by 2 power 3 into 5 power 2. Okay, so here this is not 52, 5 to the power 2. So they already factorized and gave us 2 power 3 into 5 power 2. So to equalize the powers, so we have to add, that is multiply into 5 power 1. Okay. So 23 into 5. So 23 into 5 is 3 into 5, 15, balance 1, 2 5s are 10, is 11. Divided by 2 into 5. So the power value for both 2 and 5 is 3. So the answer is 115 divided by 10 to the power 3. So we have to keep 10 decimal places, that is, 3 decimal places before. So 115 divided by 10 power 3 is 1000. So there are 3 zeros. So before 3 values, you have to keep the decimal point. So the answer is 0.115. Okay. So next problem, 6 divided by 50. So this can be factorized directly. 2 into 3 is 6. 3 into 5 is 50. So 3 is cancelled. 2 divided by 5. So to bring 2 power n into 5 power form, so I multiplied by 2 on denominator and numerator. So the value is 2 2s are 4 divided by 10. So only 1 0. So before 1 point it is decimal. So 0.4. Okay. Next one is 35 by 50. So 35 can be factorized as 5 into 7 divided by, so 50. So let me factorize 50 using 2. 2 2s are 4, 5 2s are 10, again 5 5s are 25. So it can be written as 2 into 5 square. So here the power of 2 is 1. So to equalize the powers, so you can multiply by 2, or just here you can cancel 1 5. Okay, so if you cancel 1 5, this can be automatically equalized. That is 7 divided by a 5 is cancelled here. That is 2 into 5. 1 5 will be cancelled in the denominator. So 7 divided by 10. Okay, so I write here 7 divided by 10, so which is equal to 0.7. So these are the problems which have terminating decimal expansion. We have found the terminating decimal expansion. Okay, okay friends, can you understand? So let me go to the next question, that is last question of this chapter, question number 3. So the following real numbers have decimal expansion as given below. So in each case, decide whether they are rational or not. If they are rational and of the form P by Q, what can you say about the prime factors of Q? Okay. So that is, they gave a rational number. Okay, not it is, no. They gave a decimal expansion of some number. We have to check whether it is rational or not. So to check whether it is rational or not, we proved some theorems. That is, the denominator is of the form 2 power n into 5 power m. Then we can say the given number is a rational number with terminating decimal expansion. Okay. So the condition we have to follow that. That is, we have to find the denominator. So here, how many points are there? 1, 2, 3, 4 here. Before 9 points, there is a decimal. So the denominator can be written as 10 to the power 9. So this 10 can be expanded. That is, 10 can be written as 2 into 5 to the power 9. So that is nothing but numerator divided by 2 power 9 into 5 power 9. So this follows this form. That is 2 power n into 5 power m. So we can say that the given decimal expansion is a rational number. Here the denominator is of the form 2 power n into 5 power m. So we can say that this number is a rational number with terminating decimal expansion. Okay. So this expansion terminates, that is ends. So we can say this rational number has a terminating decimal expansion. Okay. So let me take the next problem. 0.12012001200. Okay. So here if you check this decimal expansion, this does not terminate. Also, the number is not repeated. Okay. So we cannot say this decimal expansion is a rational number. The denominator should follow this. That is, the denominator should be of the form 2 power n into 5 power m. Before that, the decimal expansion should terminate. Here, the decimal expansion does it terminate, that is, doesn't end. So we can say that since the given decimal number is non-terminating and non-repeating. Okay. So here 120, next 1200, next 12000. So it is not repeating. So non-repeating, it is not rational. Okay. So next number, here this is same as first one, but here they gave a bar. So this bar means this number repeated, but it is not terminating. That is non-terminating repeating. So we have also proved that if it is non-terminating and repeating, it is a rational number. But denominator will not be of the form 2 power n into 5 power n. So these all three are examples for the theorem 1.5, 1.6 and 1.7. So if it is a rational number, if the denominator is of the form 2 power n into 5 power n, then we prove that it has a terminating decimal expansion. Okay. So if the decimal expansion doesn't terminate and doesn't repeat, then the number is not rational. If the decimal number is non-terminating and repeating, we can say that number is rational, but the denominator will not be of the form 2 power n into 5 power n. So we have come to the end of chapter 1. So in the next video, I will post video on extra questions on chapter 1. If you are interested, you can check. Okay, children. So thank you for watching. So if you like this video, just like, share and subscribe and hit the bell button for further notifications. Okay. Thank you for your support.